Good morning. We are back. I remember something about what we were doing yesterday. So, oops. What we were looking at. We were looking at, whoops, move this over here. The variance estimate of Gaussian processes as well as the overall fit to determine how we want to make use of these in our hyperparameter sweep algo, because the defaults really don't seem very good. So stuff like this is kind of interesting. Hi, welcome. Morning. Oh. Man. It's tough because here, the solution is not necessarily to fit the curve. How can I get something that's more representative, I wonder? And then how can I figure out whether the thing that I come up with is going to be useful for actual real problems, or if I'm just overfitting to the synthetic task? Hi, morning. Welcome. Well, see, the issue here that I have is that I don't think the linear kernel's really not doing what I want, right? Like if I were to put a linear kernel, it's not like piecewise linear or anything. Yeah, so if I just do kernel, linear kernel. Right, it just kind of does this. It fits a line to this part of the data over here. which is where the support is. This is where your real data points are, and then it's trying to extrapolate and then if I do like a really soft matern kernel instead, what if I do a really soft matern kernel? See, this is so awkward, like, how stupid is that? Not this one. This is back to just being a matern kernel, right? Yeah, so that doesn't help at all. See, what I want this, and then I want it to just drop here. That do something? Ah, that does do something. That does do something. Okay, so we just have to come up with a good mean function then, right? It's very silly because yeah, the contribution of the Gaussian process is just screwed up. It's reverting down to 0. Hmm. Let me see something. So if we take okay, so this is this, and then we do E, we do this. Okay, so here's your distance. Let me see if I can do this. Start. arc sort. Oh wait, I don't need this. They're already tensors. So something like this. Okay. Um, and then if we expand K, you see it dips down here. It should dip down more than this though. Because without it, you get this, right? So it doesn't dip down very much at the moment because of the kernel. That's fine. Here, hold on. Hold on a second. Push return. Do this. Okay, so here, this is just the matern kernel, right? Now we do mean function. How many points do we have? 100 points. Am I doing this right? Let me see. E X array mess this up. Hold on, I think I messed this up. This should be very easy. I'm just half asleep. No, I did have it right, didn't I? Wait. No, this is bogus. What am I doing here? For each sample, you're comparing, you're going to find the nearest x. Well, hang on. We can test this. Return x.mean. Right, we can just do that. Because it knows y.mean. We can just do that. Okay, same exact thing. So I thought that's a little weird. Points mean is 1. Guess the mean is 1. Okay. So that is correct. Just being silly. We'll leave that alone. So this is what we have at the moment. We have this with the nearest neighbor metric. This is over all the neighbors. And if we change y to be like, or k to be like 10, then this is something that's a fair bit better here. Taking this neighborhood, if we did k equal 1, this is just like a nearest sample, right? So this will give us like a flat line. Yeah, this gives us perfectly flat line just from the nearest point. Cool. And then let's see what happens when we add in like one extra point like this. Okay, interesting. So we get this sort of behavior. I actually like this. And then if we change k to 2 here, does this substantially change the shape? A little bit, not really. And then if we use, because I think it is more reasonable to use like a k of like 5 at least. Or maybe like, I don't know, square root num points. Okay, so how's this happen? That's weird. Is that consistent? Yeah, so there's a point here. There's got to just be some weird discontinuity. But this is, I think, what we want. Let's see. Without this, what does it do? So without this, yeah, you see it drops all the way back down to 0. So this is kind of silly. I don't know how silly it is, to be honest. I think we need to do this on the real data, don't we? Well, synthetic data still, but on the real problem. This is still not amazing. It's cool that we found a way to do this. K to 1. Hey, set up the repo. Welcome. Let me know if you run into any difficulties. Should I now directly start making an end? Yeah, here. Remind me, because I've had like a ton of different people with a ton of different users. Did my camera just freeze? Hang on. Okay. Yeah, remind me what conversation we had, because I've had like 5 or 6 people in the last few days cycle through here on a bunch of different accounts with Twitch, YouTube, and X. Jog my memory real quick, would you? And I can show you where the M stuff is. So we have the docs here, but also, and this is in the docs, this is the simplest possible environment. It's a tiny little Python file. This is all that's in here. There is a tiny little test file in C. This is all that's in here. And then here is the whole code. Here is 115 lines for just a very simple test environment in renderer. So I suggest using this as a template, just like copy squared over and then go from there. Because you can see all the logic is in squared.h here. How to set up on Mac, yeah, okay, gotcha. Yeah, it'll work on Mac just fine for you. Just get Clang 18 and you'll be good. Well, the thing that I didn't get from you, right, was what you're trying to do with PufferLib, I don't think. Did you say what you were trying to do with PufferLib? Do you have a specific problem? Are you new to RL? Are you experienced in RL and like trying to use it for something like that? I don't know if I got that background out of you. Because you know what I suggest will differ depending on circumstance. New to RL, so want to figure it out. Good experience in Python, like your glasses. Thank you. They are the cheapest possible glasses because I just end up getting new pairs of them constantly. And I typically just wear them when I'm being lazy, too lazy to put contacts in anyways. Good experience in Python, new to RL. So yeah, in that case then, for newcomers to RL, I wrote a guide specifically for you. This is my RL Quick Start Guide. I suggest spending 80% of your time that you're going to allocate to RL, like building new stuff and like learning by building, and then 20% of time going through the formal resources here. This gives you just a very quick outline of stuff in reinforcement learning and a little bit of perspective. It links a bunch of papers that, again, 20% of your time that you're going to allocate this on papers. And then it suggests that you essentially build a very simple test env and get an agent doing something on a new task, right? And I have a template for you, squared as a template. All the other environments that are in here can be used as references. And then myself and others are around on Discord if you get stuck. Oh. You're not here to ask me about crypto, are you? I've had a bunch of accounts getting very creative with that in the last couple of days. Yeah, the thing that's weird here is I don't think this is reflective of what we see on our Gaussian processes. Maybe it is. Maybe I just didn't bother to plot it. Header files main logic. Yeah, so the way it works, right? All the logic goes in the header. The C file is just a standalone test. I suggest not recompiling the whole Python stack every single time. So when you're developing, you can just use scripts build ocean sh, and then that will let you build locally. So you can test locally in C. It's very convenient. It's very, very fast. And it comes with, if you use Clang 18 on a Mac at least, you can get like fsanitize flags with the address sanitizer. So then you don't have to deal with memory faults and stuff like that. Basically, C becomes as easy as Python. And then, yeah, binding to Python. Python's the intermediary layer. And then Python is just the top level. Figure this out. We can technically use this, can't we? Yeah, wait, we can just hack this. Okay, I know what we're gonna do. This is gonna be good. Hopefully I can get this done quickly enough in the morning dev session. Take this. Put this. here. Okay. No, not that much. It's indented 3. Oops. Okay. And now we have costs and raw scores. Is this more crypto? Did I guess? Yep. How'd I guess? No, I don't deal with crypto on here. I'm gonna give you the benefit of the doubt and assume that, and just like suppose that you're not the same crypto person who's been harassing me on here for the last few days. But no, I don't do crypto. I do AI. This is all reinforcement learning development. No. It's quite the coincidence then, because I really don't have anybody following me for crypto. So you can imagine the suspicion. I've been doing reinforcement learning here for the past, I don't know, when have I been doing this live since? Closing in on a year now. Why did Conda compiler need C prefix? Why did the Conda compiler need C prefixes? Conda ships are just a horribly broken C compiler, man. I don't even know how they managed to break it as badly as they have. All right, because the error that the conflict of name error that this causes shouldn't even be possible. So I don't know how they managed to break it that badly. Do invest in crypto privately? Not in meme coins. I own a couple ETFs as a very small fraction of overall investments, I believe. Mostly I just have tech stocks. And then Puffer has been the latest investment, because buying your own hardware is expensive. But we're well positioned for that now. We just got a little bit of additional revenue yesterday. It'll be useful. And yeah, a couple more things on the horizon potentially for Puffer as well. Really, I think just one more good contract and we'll be very comfortable. And any more than that will be sitting very pretty. Okay, so we have the raw values here. And then what do we plot here? Unnormalized score mean and unnormalized, what is it, cost? So we do cost mean and unnormalized score mean. Is that what we do? That's neocarbs. I'm not gay, man. I'll take it as a compliment, but I'm not gay. What happened here? Oh, max. Oops, that was dumb. Really? What the heck? Well, this is moderately insane. Hang on, how is this? What? Well, that answers why stuff isn't working. Holy hell. I not fit the model or something? What? I gotta stop streaming so late. I'm like half asleep this morning. Probably have a hard cutoff around 9 or whatever. Come on, this should be basic. Brain is just not processing right now. Unnormalized. Oh wait, do we need the untransformed one? Hang on, I think we need... This is still transformed. We need untransformed squirming. There we go. Alright, do these predictions still suck? Much better. Way, way better. Okay, this is something we can maybe work with here, right? Because we can actually see exactly what's going on here. This is kind of cool. This is actually not terrible, I think. Like this is the linear kernel, presumably, right? It's giving us this correlation. Actually, let's we should be able to verify that. Right, so if we get rid of the linear kernel, what happens? So from this is what we had before. Yeah, so we get something quite different. Well, the support data is going to be a little different here, right? It's not as crazy different as I would expect. Well, this is not good, right? Like, look, it's overfitting right here. It's overshooting. It's basically has this flat prediction here, and this is not correct. I don't know where it learned this from. And how? Okay, so this is the linear kernel, but the thing is it's log linear because it's done in log space. And what test is this on? Let's do synthetic log test again. So like here, this, damn it, broke my terminal. Okay, so this log fit should actually be decent for a good number of tasks here. Yeah, so this is the log fit that we get. It pretty closely matches in the support. And then it starts underfitting a little here. This is pretty decent overall. And I think that this is a good starting point because most cost curves should look like this. So linear kernel in log space is a good idea. And then when we add in the matern kernel, okay, we're gonna do this and maybe it'll stop breaking my freaking terminal. And then what's the matern kernel do for us, right? Oh, no, that's pretty good. Now the question is, why is it so confident about all this? Like, if we do kernel is matern kernel, and then length scale, does this give us what we would expect? All of our predictions are right here somehow. That does not make sense. They should not be able to go to the left like that. They should only be able to go Oh, you are using it to predict cost as well, so it can actually shift to the left. That's funny. We really should divide this cost data by max cost or something, shouldn't we? It's actually kind of cool how with the log fit, it's just decent on its own. Far too confident is the thing. Let's see if we can just scale the score prediction one by a little bit like this. That's very weird. So, wait, what? Hmm. It's very weird. It pushes the cost. Why does it do that to the cost? Hang on. You score it, right? These should be independent. That doesn't make sense. Okay, yeah, we gotta figure something out here because that doesn't make any bloody sense. BP score. Maybe we found something here. What is this thing trained on? Normalized log cost, right? And this is only trained on stats from here. If I comment this, it's going to be different, right? Is that the case? Wait, what? Hold on. Excuse me. Something's weird here. Okay, so this dot train is not, hold on. This dot train is just a train mode. Use the source installation method. Yep, that's fine. Robust way to check installation. Yeah, see if you can run stuff. Though, did I break something lately with this? I might have broken something for you just yesterday. Hold on. I want to get off of this branch at the moment. So the one thing I think I broke yesterday that you might have to look at, it should take you 2 seconds. So this is in the docs, I believe, as well, but we use this script to build locally. And where is it? Yeah, this flag, you're going to have to swap this for the Mac one. You'll see there's ArrayLib like 5.0 Mac OS or whatever. You just have to swap this path and this path. You should be able to build for Mac. So you can just build some of the environments. You can build like Neural MMO3 or Squared or whatever and see if it works for you. Morning. So I have no idea where this score data is coming from because I don't think we're fitting to this. Hang on. Is this train not what I think it is? So I'm not training the GP here at all. That doesn't make any sense. I mean, it is a log distribution by default. Hang on. So if I just comment the kernel, will it mess it up? If I comment the linear kernel, which is in log space? No, it's still a perfect fit. Okay, well, something is bizarre because it shouldn't be training. Is somehow... Wait. I'll be back in a few minutes. I gotta figure this out. Be right back. Okay. We have the phantom Gaussian process to deal with now. So we need this thing, right? And then the question is why. It's probably going to just be something dumb. So if you don't estimate cost, the cost stays at 0 because it's a Gaussian process. But now, you'd expect the cost to go out, but for some reason the score also gets predicted. Why does the score get predicted? Because, let me see. Untransformed. Is this what I use? Oops. Untransformed score mean. And then I plot untransformed score mean. Okay, so this comes from a normalized score mean, which comes from normalized score mean, which comes from the Gaussian process, right? Suggestions comes from these points. So yeah, I don't see how an untrained Gaussian process is producing this. Especially with, we just have the matern kernel, right? I guess it's possible. Okay. Maybe there's some weird thing with this. Wouldn't think so. Super fast, got it running. Great. Yeah, Puffer is meant to be easy. If it is not easy, I've screwed up. But also there are kind of a million other things demanding my attention, so things get fixed in waves. At the moment, it's figuring out what is wrong with hyperparameter opt. Really not. I mean, is there some quirk? Is there like some quirk with this? Set the data. Okay, so it's somehow it's running training. Yeah, somehow it's running training even though I'm like telling it not to. Fine. That's just Pyro being weird. It's not me being weird or stupid, it's Pyro being weird and stupid. Fine. What if we plot the variance? Do we plot the variance? Is that what we should do? Gear Lab Sim to Real. Mimic moves. Is this Jim Fan? I have Jim Fan muted for he's like one of the worst defenders for like just inflated claims about stuff and generally misrepresenting scientific work. So if that's from his lab, I have very little faith. If you want documentation of that, just go look back at how he presented Voyager and then go read the real paper. And the funny thing is that the group does actually does good work. It's just you can never tell what the work actually is because it's always misrepresented. So for the folks on YouTube, what I'm currently trying to figure out here that's driving me nuts, um, the Gaussian process, or Gaussian processes here, are what we rely on to estimate how good a set of hyperparameters is so we know if it's worth running the experiment or not. It's giving weirdly biased predictions where it is overconfident in its estimation. It's overconfident in its predictions in regions where it really shouldn't be. Also, why is what the hell's wrong with my plugins? We're gonna work. Leave me my typing. Does this do anything? Not at all. Doesn't do a thing. Did the kernels turn off the stream yesterday? No, the Linux drivers did that. If anybody knows how to fix frickin' Ethernet on Ubuntu 24, that would be great. Because on average, once every day or two, it will just randomly die, and nothing I do gets it to turn back on without rebooting. I tried all the basic stuff I could think of. Freaking Linux drivers. There's just no variance, huh? Just no variance. If I look at this, yeah, it's completely confident in its predictions. On the entire frickin' Pareto front. All right. Is that kernel dependent? Kernel, linear kernel. Let's see if it's still very confident. Yeah, so the variance is just a useless metric. Huh. Huh, huh, huh. See, the problem is you've got top of the morning to you. I would love to know why it is so confident all the way out at the extremities. Should my states be Markovian for RL? You can ignore the existence of that word and you will be better off. Yeah. The theoretical results are they quickly go out the window, all the guarantees. With stuff that we throw RL on, it will still work. What you should think about is whether the problem is actually learnable. Okay, you know what? Maybe there is something here, which is why is this thing so confident all the way out at the end? Oh, you know what? So put a bump in input space or output space. Yeah, okay. I guess the support set is not intuitively what we think it is in this graph. Fine. Because it's actually the higher dimension. Fine. Okay, so we can't rely on variance. And a lot of the utility of these things goes out the window. The thing is that, like, the exact reason I'm using Gaussian processes at the moment for this is the thing that's not working. Okay, let's try some stuff. Try this. What's this do for us? Holy. All right. So at least get this to have a little bit of shape, right? What was it, 2 times? Been following? I understand 10% of what you do, but I believe in it. I mean, I'm also not explaining what I'm doing here amazingly, because I'm trying to think about this at the same time. I have some videos that are... Have you seen the iceberg video? The iceberg video is a pretty good outline. It's a decent balance of technical depth and high level. I mean, like, the thing I'm trying to do at a high level is not ridiculously complicated, right? Reinforcement learning is an important branch of science. The field has been subject to absolutely terrible engineering and performance optimization for the last 10 years. This has made all of research go 100 times slower than it should have. This means that you run 100 times fewer experiments than you should. This means that your results are very inconclusive, so the whole thing is very wishy-washy and feels very janky. I'm making everything fast. This lets us do consistent and accurate science. I have made everything fast, or a lot of it fast now. Now I'm using all the fast things that I've built to do really consistent and accurate science. This will make reinforcement learning broadly useful this year. Sure. Okay, here's an idea then. What if we crank up this one up? So now what this should give us is the Gaussian process should sample very far away from its support. Yes. So you can see there are no supporting data points in here, but it's still like making confident predictions. This is not good. Okay, let's look at the kernel. Look at the matern kernel first. Let's really crank this. Oop. I guess that is a regex. Let's not do that. I gotta go in a little bit as well. But I want to at least get something figured out this morning. Here, let's do this. So now it's sampling crazy points. But did I break it? Oh, I see. Well, that's awkward. Okay. Let me explain what's happening. And I figured this out earlier. I don't know why I forgot about this. So both cost and score are being modeled by a Gaussian process. When you're outside the support, which means outside the space where the points are informing you, Gaussian processes go to 0. So for support, for score, that's what you want, maybe. But for cost, you don't want it to systematically underestimate cost. So what you need to do here, and this is what we'll get done for right now. Where's the mean function? That's cost. So we'll do, where's this? Max log cost. Get rid of that. Okay, so GP cost, not mean function lambda x. Let's see what this does. heck? You know what we can do instead that'll be way easier than this? Hang on. IDX. We'll just do max cost IDX equals max cost. I think this is 75. We'll just do where is it? Normalize max cost equals X. Okay, way better. Immediately way better. Yeah, that was it. Okay. Jeez. In fact, we could even have it be more aggressive. So if I do this, then the really unconfident predictions will get pulled. They'll get stretched even more. Boom. So we will mess with this and figure out the appropriate value here. This one seems too much. But effectively, you want to assume that when you don't have information about a point, it's going to be more expensive and perform less, not as well as you expect. So score function seems to be taken care of. Though I'm not sure, I don't think it reverts to 0. I think it reverts to like some intermediate point. We'll have to look at that, but this is this is big progress. That's way better than before. Actually, this would explain why cost was being consistently overestimated as well. Freaking Gaussian processes, man. I'm gonna keep using these for a bit because I mean, these seem like very useful in hyperparam optimization literature overall, but I will not be surprised if we just get to replace these with logistic regression or something, because these are so unwieldy, and yeah, there are all these details that you need to get right or you're screwed. All right, I'm gonna go get some breakfast. I'm gonna go for a run. I got a couple meetings, and then I will be back working on some stuff. Maybe this, maybe some robotics. We shall